In this video, we're going to use cost, revenue, and profit functions. It says, suppose the price, demand, and cost functions for the production of soldering irons is given respectively by P equals 302 minus 0.2x, so that's the price equation, and the cost equation is 348 plus 81x, where x is the number of soldering irons that are sold at a price of P dollars per iron, and C of x is the cost of producing X soldering irons. Find the marginal profit for manufacturing 90 soldering irons. So, marginal profit, that's probably the first thing we need to write down, that marginal profit, so we're going to call that MP of X, is equal to the derivative of the profit equation. Now, marginal profit is just basically finding the amount that you make in profit per product sold. So to figure all this out, though, we need to figure out how much profit we've got. So the first thing we need to do is figure out the revenue. So we can say revenue is actually equal to X times P. X is the number of soldering irons sold, and P is the price. Now you'll notice that the price is in an expression here, which is kind of weird. We're not used to that. But you got to remember, when you buy things in bulk, you usually get a discount, and this negative 0.2x is representing the discount off that 302. So we're going to say that this is equal to X times 302 minus 0.2x, which would be 302x minus 0.2x squared. So that's our revenue equation. Well, we can say that the profit equation is equal to our revenue that we make. So let's say we make $6 billion in a year, minus our cost, and our cost was $4 billion. Well, $6 billion minus $4 billion would give you $2 billion for your profit. So that's why we're using this equation. So we start by using the revenue, which was 302 x minus 0.2x squared. And we're going to subtract out our cost equation, which was 348 plus 81x. So I get 302x minus 0.2x squared minus 348 minus 81x. Let's combine some stuff together. That would be negative 0.2x squared minus, if I combine the 81 with the 2 there, that would be minus 383x minus 348. And that would be our profit equation. So just combine some like terms there. Now we'll take the derivative of this to get our marginal profit. So marginal profit is going to equal P prime of X. We do the derivative, we get negative 0.4x minus 383. Now they want to know in this equation the marginal profit for 90 soldering irons. So I'm going to say MP of 90 is equal to negative 0.4 times 90 minus 383. So when I do that in the calculator, I end up with negative 0.4 times 90 minus 383, which is negative 419. I feel like I made a mistake somewhere, and I'm trying to figure out where I made that mistake. So we did the revenue minus the cost, and the revenue was 302x minus 0.2x squared. Yep, that makes sense to me. Minus 348 here, minus 81x, So when we have this, oh, that's not negative here. That's a positive. I screwed up this piece right there. So we're gonna fix this. So 302 was positive minus 81. That should be 221. This should not be negative 383x. That should be plus 221x. That was my mistake. I didn't subtract those correctly. So what's that going to do? Well, that's going to change our profit equation, and that'll change this equation. So I'm just going to kind of cross those out, and I'm going to put an equals here, and I'm going to get negative. When I take the derivative of this, I get negative 0.4 x still. Derivative of this, though, would be 221, and now obviously the derivative of the constant stays the same. Now when I try to find MP of 90, that would be negative 0.4 times 90 plus 221. Now the reason how I caught that not being correct is both of these are negative. I'm going to get a profit that is negative. That doesn't make a whole lot of sense there. So I end up with negative 0.4 times 90 plus 221. And I get $185. So that's $185 for our marginal profit.